Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on today's video, I'd like to ask you to please give this video a thumbs up, subscribe to the channel, and engage with a comment below. In this video, we're looking at Unit 3 on similarity. This is Lesson 3, Measuring Dilations. The learning goal for this lesson is to dilate polygons. We have one learning target. I know that when figures are dilated by a scale factor of k, all lengths in the figure are multiplied by k. For glossary terms, first we have dilation. A dilation with center P and positive scale factor k takes a point A along the ray PA to another point whose distance is k times farther away from P than A is. Triangle A prime, B prime, C prime is the result of applying a dilation with center P and a scale factor 3 to triangle ABC. What that means is that the blue triangle is the original, the green triangle is the image, and by multiplying the length of each side by 3, we have now created the green triangle, which is the image. Our other glossary term is scale factor, the factor by which every length in an original figure is increased or decreased when you make a scaled copy. For example, if you draw a copy of a figure in which every length is magnified by 2, then you have a scaled copy with a scale factor of 2. So if you look at the bottom, on the left, the smaller one is the original figure. They have multiplied the length of every line in the original figure by 2, and that has created the scaled copy on the right, which is now 2 times bigger than the original. Now that we're done with the introduction, let's go ahead and get started on the practice problems.
It's all connected, man. The Pythagorean theorem, the Illuminati, my nap schedule. It's all part of a grand design to keep us from the truth.
Practice problem number 1 says pentagon A prime, B prime, C prime, D prime, E prime, which is the green pentagon, is the image of pentagon A, B, C, D, E, which is the blue pentagon, after a dilation centered at F. What is the scale factor of this dilation? So if you look, we have two different measurements. We see lines on the blue pentagon that are 3 that when increased become 5. And we see lines on the blue pentagon that are 6, and when they are increased, they become 10. So if you want to find the scale factor, what we do is we take the new measurement and we divide it by the original measurement. So if we do that, then in the first case, we have a new measurement of 5 divided by an old measurement or original measurement of 3. So our scale factor would be 5/3. thirds. The other option is that we have a new measurement of 10 divided by an original measurement of 6. I can tell that this is not in simplest form because 10 and 6 can both be divided by 2. So if I do that, then my simplified measurement becomes 10 divided by 2 is 5, and 6 divided by 2 is 3. So the scale factor is 5/3. Now, if you wanted to check that, we can try. What happens if I take 3 and I multiply it by 5/3? Well, 3 times 5 is 15. And 15 divided by 3 is 5. 3 became 5. And that's what we saw. And then if I want to try it with the other one, we had original measurements of 6. When I multiply that by 5/3, 6 times 5 is 30. 30 divided by 3 is 10. My lines that were 6 became lines that were 10. So we can see that that does work. So anytime you are trying to find the scale factor, simply take your new measurement and divide it by the original measurement. I hope this helps make sense of things for you. If you do still have any questions, please go ahead and leave a comment below.
You kids have it easy. Back in my day, we didn't have calculators. We had to use our noggins.
Practice problem number 2. A polygon has perimeter 12 units. It is dilated with a scale factor of 3/4. What is the perimeter of its image? Well, if I know my perimeter is 12, and I know that my scale factor is 3/4, then I can simply multiply them. 12 times 3 equals 36. 36 divided by 4 equals 9. So my answer is 9 units. If you think about this, remember what I said in the previous problem. We said that the new measurement divided by the original measurement equals the scale factor. So if I were to rearrange this and I wanted to find the new measurement, then I can simply multiply both sides by the original measurement, and I now have new measurement equals scale factor times original measurement. So you can see how I figured this out. If you wanted to double check, we're now saying that new measurement is 9. We said the original measurement was 12. Well, I know this isn't in simplest form because they can both be divided by 3. So if I divide the top and bottom by 3, then 9 divided by 3 is 3. 12 divided by 3 is 4. And there is my scale factor that they gave us. So when I double check, I can see that I'm correct. I hope this makes sense to you, but if you do still have any questions, please feel free to leave a comment below.
I'm once again asking you to solve this equation, and don't tell me we can't afford to get to the answer.
Practice problem number 3. Triangle ABC is taken to triangle A', B', C' by a dilation. Which of these scale factors for the dilation would result in an image that was larger than the original figure? In order to solve this problem, I need you to think back to Algebra 1. We said if we had a number that was larger than 0 but smaller than 1, then it would get smaller. Because when we multiply by a fraction smaller than 1, we get a smaller answer. Then we said that if we multiplied by 1, then our number stayed the same. And finally, we said that if the number was larger than 1, then our answer would get larger. And that's the same concept on this problem. So if we look at A, 3/5 is less than 1. Because it's less than 1, this is going to get smaller. If we look at B, 13/7 is smaller than 1. So this is going to get smaller when we multiply. Choice C, 1 equals 1. Anytime I multiply by 1, my answer stays the same. And my last choice, 4/3, is greater than 1. So when I multiply anything by 4/3, my answer is going to get larger. And that's what we were looking for. We were looking for the scale factor that would result in a larger triangle. I hope this makes sense to you, but if you do still have any questions, please feel free to leave a comment below. So I just want to review the learning target for this lesson. It said, I know that when figures are dilated by a scale factor of k, all lengths in the figure are multiplied by k. If you understand this, then if you're given the original length and you're given the scale factor, then you should be able to multiply them together to find the image lengths. In reverse, if somebody gave you the image lengths and gave you the scale factor, then you should be able to divide the image length by the scale factor and get your original lengths. And if you know the original length and the new length, then you can divide the new length by the original length to get the scale factor. So I hope this lesson has helped you understand that. I hope you feel comfortable using two of them to find the third, no matter which combination it is. But like always, if you do have any questions, please feel free to leave a comment below. If you found this video helpful, please give it a like. If you like these videos and want to see more, in the bottom left, YouTube is recommending another video for you, and in the bottom right, you'll see the subscription button. It would really help out the channel if you would subscribe, and I look forward to seeing you in the next lesson.